last video we saw how we did the pre-processing of the CPU column, where we segregated the Intel iCore, i5, i3 and i7 processors into separate clusters, and other variants of Intel processors into a separate cluster named as other. And then we had another kind of processor which was named as AMD. So we also categorized processors which are not part of the Intel family to be part of AMD family. And then we said that not only AMD is possible, you can even write it as others. So we did the complete pre-processing of the CPU column, and we dropped the CPU column, and we saw how the price is getting inflated with the various kind of processors in market. Now we will head up on the RAM column. So we will see what kind of things does the RAM column provide. So we just see the count plot of RAM. We see that almost 600 or more than 600 people are using 8 GB RAM a laptop, and the other major quantity people are using 4 GB. We rarely find people who are using 12 GB or 6 GB. We find few people who are using 16 GB RAM as well. So let's see the bar plot and with respect to price. Here we see that the RAM is having a good relation with price, as we also saw in the correlation analysis that RAM was contributing almost like 74% to the price. So, and this bar graph is also stating that like as the RAM size is increasing, the price of the laptop is also increasing. A linear growth is clearly visible here, right? If you purchase a 64 GB RAM, obviously you will get more than 2 lakh rupees. The price of the laptop would be that. Okay, not even 64. If you try to purchase even 32 GB laptop, there are high chances that there is a particular laptop which is having more features additional to 32 GB RAM, and the total cost becomes more than 2 lakh also. So this is that. And the average cost would be nearly to 1,50,000. If you're using 32 GB RAM, that means that 1,50,000 is like an average price for 32 GB laptop. There's no kind of average given for 64 GB laptop, because there are no laptops in scale as per now in the market of 64 GB, or maybe the dataset doesn't has it. There may be many laptops which are in production, which didn't come or which are not released yet into the markets, but as per now in the dataset they are not that much. So maybe like 2 or 3 laptops are there which are using 64 GB RAM, but not more than that. So that is why there is no tick over here like this. And most of the common public use 4 GB and 8 GB, and we can see that that is almost like reasonable prices only, and everything is common here. So RAM column is very important. We cannot skip this column, as it is giving a good correlation also. Now about the memory column, so we will separate the type of the memory. So if we look at the memory column, so in the memory column what is happening is basically we see that we are having SSD, we are having HDD, and we are having a combination of SSD and HDD. So in few laptops, if you view on Amazon or Flipkart, they say that we are having 128 SSD and 1 TB HDD. We are having 256 SSD and 1 TB HDD. So there is a combination of SSD, HDD, and there are few laptops which use only SSD, and there are SSD, and there are few laptops which use only hard disk. So we are having 3 kind of things now, and there are few laptops which are using even flash storage, which is nowadays which has nowadays gained a lot of popularity, flash storage. And yeah, so there are many variants which we can see in this. So this is also a column which we need to pre-process a lot. So let's see the counts. So we have to do a lot of pre-processing here. So now we will apply the regular expressions as usual. So this expression will remove the decimal space. For example, 1.0 TB will become 1 TB. So a very simple regular expression which I have written here. So in memory column, convert this memory column into string maybe that is an object. It's better to convert into string. Even though it is in string, it looks for you as a string, it's better to convert into string because you don't know when sometimes the things change. So it's better to convert into string. So we do as type as string, and then we replace all the decimal points or the digits which are coming after the decimal points with this. So this slash dot 0 means whatever is coming after the decimal, please truncate it. That means if it is 1.0 TB, it will become 1 TB. And regex equals to true means you do this for every column, sorry, every tuple which is present in this df of memory column. Okay, so once we get this done, next what we want is, we want to replace the GB word with this. So basically what we did is, there are few columns where we are having 1. See over here, I was saying about this 1.00 TB, 1.00 TB. So there were few columns which we noticed, and to overcome this only we did this line, the fifth line. To overcome those kind of rows only we did this, right? Now what we need to replace the GB word or TB word or SSD word. Mostly we need to replace this GB word because this GB word is common everywhere, it is common. So we will replace this GB word with blank space. That is done in line number 9. And then this TB word will be replaced with 000, and it will be considered as GB only. So 1 TB is nothing but 1000 GB, right? So the same thing, that analogy, based on that analogy we are doing things. So if it is 1 TB, that means 1 and then TB. After TB we are truncating it, we are truncating the TB to 000, or we are replacing the TB with 000. That means 1000 GB. So we need to convert, we are maintaining a scale of gigabytes only because most of our configuration is in gigabytes. So we want to keep that gigabytes as usual. So we are applying that kind of mechanism here. So if we find any kind of TB, we will replace it with 000. Now split the word across the plus character. Yeah, so there are few things, there are few places where we have plus characters as well. So this is a kind of a combination thing. So if you are having a configuration of 128 GB plus 1 TB HDD, so what this will do, first we will I'll just show you an example how the flow goes like. Okay, so this is 128 GB and 128 GB SSD plus 1 TB HDD. So the first line, that is this 8th line, what does this say? It says that after decimal, is there any decimal? There is no decimal, so this will be as it is only, no problem. Now what will happen? Now in the next line, that is line number 12. So in the line number 12, what will happen? They said that df of memory is equals to df of memory dot str dot replace GB with space. So this will get replaced like this, and this is space, and then SSD. Okay, and then we get 1 TB 1 TB HDD. After the line number 15, the result is something like this. Now, is there any TB? Yes, there is a TB. So we have to replace that TB with what? 0000 SSD plus 1 1 2 3 space HDD. So after line number 21, the string is looking something like this. Now what we are saying? We are saying that split the characters, split the string on plus. So if you split the string on plus, what will happen? We will get a list of characters like 128 SSD, comma 1000 HDD. We will get this list of characters, right? On the split we will get this characters. N is equals to 1, expand is equals to true. We discussed it. So that kind of mechanism is applied. And then what is happening, if we just do this, we get this kind of thing. So this is working fine. So now what we will do, we will strip up all the white spaces, basically eliminating all the white spaces. So df of first is equals to new df of 0. New df of 0 is this thing, and we are removing all the white spaces so that it becomes clean. And when we run this, we get this df of first. Then we apply changes. Yeah, so over here, what is this? So over here, as I said that when you are having HDD, SDD, hybrid and flash storage, these are 4 kinds of memory storages, right? So we have to apply some kind of pre-processing here. So what we did is, basically I'm trying to kind of make a boolean values over here, so that it is easy for us to track, or it is easy for us to do EDA on it. I'll just show you how it is. So I'm making a list to apply as hard disk, HDD, hybrid and flash storage. Now for every value in list to apply changes. So what we are applying changes, df of layer 1 plus value df of first is this, dot apply lambda x1 if value in x, else 0. So if HDD is in value, what is value? Value is 128 SSD or 128 flash storage, 256 SSD, like that, right? I said that lambda functions are kind of one-liner for loops. Okay, so the same thing. So df of first has almost like 1303 values. So for each value you check if HDD is available or not. If it is available, then it is 1, else it is 0. First you do for HDD, then you go for SSD, then you go for hybrid, then you go for flash storage. So this loop runs that. This loop runs 4 times. This thing runs 4 times. So totally 4 into 4, 16 times this entire thing will run. Okay. So after the result, what we will get is, we will get 4 columns. Layer 1 HDD, layer 1 SSD, layer 1 hybrid, layer 1 flash storage. So what is the significance of this is, wherever only HDD is used, that system, that configuration is marked as 1. Wherever only SSD is used, that configuration is marked as 1. Wherever only hybrid is used, that is marked as 1. Wherever flash storage is used, that is marked as 1. So now exploratory data analysis of this will become easy. Okay, so yeah, so let's remove all the characters, just keep the numbers. So now we are interested in only numbers, right? So we will remove all the characters. So for removing all the characters, this is the command in regex /d, means only keep the numbers. Okay, remove all the characters, or wherever you are having characters, just replace it by space. It means the same thing. So if we do this, so we get it, and then next time we will do the same kind of processing for df of new df of 1. So new df of 1 will contain these kind of records. See why we are doing new df of 1, because there are few columns which are having plus also. We just considered till now we just considered laptops which are having HDD, only SSD, only hybrid and only flash storage. We have to now consider laptops which are having both. So to get the details of them, the details are present in new df of 1, right? So we have to create this column, new df of, that is second column. So in second column we have to apply the same kind of logic which we applied here. The same kind of logic which we did here is applied to the second column as well. There's no change. And then we will convert it into integers. So once everything is converted into integers, we are good to go. Now over here, this little bit of mathematical formula which is used. Okay, so this is like df of HDD is equals to df of first multiplied by df of layer 1 of HDD plus df of second star df of layer 2 of HDD. So what does this mean? Df of first is 128 star 0 plus 0 star 0. So this becomes entire 0 for the first row. So this kind of mathematical formulas are used. This kind of mathematical simple numerical this is simple arithmetic operation which I did just in order to reduce the kind of columns over here. So I see that layer 1 HDD, layer 1 SSD, layer 1 hybrid and all, they are so many columns. I just want them like HDD, SDD, hybrid and flash storage, nothing more than that. So for that reason I am using this. It's very simple, you can trace it. Then we will drop some unnecessary columns like first, second, layer 1, layer 2 and all. And when I do this, this gets executed correctly, and then when I sample, I get the pre-processed and kind of good data set looking like here. Okay, so yeah, so we can also look at the head part of it. I just took the sample. You can also look at the head part of it and get a good insight as well. And then we will drop the memory column because we have pre-processed it completely. And then we will see the correlation of now we see that SSD is giving good correlation, flash storage is giving NAND because there's almost nothing which gives a good correlation there. We see that SSD is giving a good correlation here. So we will talk about the correlation analysis of these memory columns in the next video. Till then, do practice and do revise the code here because this is a very important part which I discussed.